ahead and get started reviewing Chemistry Unit 1. So again, make sure you have a pencil and a calculator, hopefully scientific, and hopefully one better than the one that's on your computer. Just a piece of paper to write stuff down. Alright, so we're just going to go through some basic stuff, and Unit 1 is going to be kind of an overhaul. I'm going to try to get through it quickly. So keep in mind this was an entire unit I'm trying to get into about 30 minutes or so. If you have questions, just let me know. So some basic just words. Hypothesis, you guys should know that's an educated guess. I see a lot of people mix up theory and law. So theory is why or how something happens, so it's kind of an explanation. The law is what actually occurs. So if you were to talk about the theory of gravity, you would be explaining because of the masses and the distances of two different objects, the force that you get between them. But the law of gravity says, if you hold your pen out and let it go, it's going to drop to the ground. So theory is more of an explanation. Law is what actually happens. So it's an actual action. Another one I see missed is precision and accuracy. So accuracy really just means the correct value, the one that's actually true. So it's a little bit different than precision. Precision refers to the degree of an agreement among several measurements made in the same manner. Really all that means is precision is just about repeating what you did. So that's kind of why we do more than one trial in a lab, is to make sure we have precise results and they weren't just flukes. So here's an example. A really good way to show this is just by some targets. So this first example, you can see that it's neither accurate or precise. It's not hitting the bullseye and it's not repeated. If we look at the next one, this one is not accurate because it's not hitting the bullseye. It's precise because they hit the same spot several times. And then this last one is accurate and precise. They hit the bullseye and they repeat it. Another thing that you guys need to be able to do is explain relationships. This is going to be important throughout the whole year, talking about direct and indirect. So direct just means that as one variable changes, the other one goes the same way. So as one goes up, the other goes up. And indirect, which is also called inverse, they mean the same thing, is just the opposite. So as one variable changes, the other goes the other way. So as one goes up, the other goes down, or as one goes down, the other goes up. So if you were to see this in graphing, these two are direct. You can see on the graph as y gets bigger this way. That is not a straight arrow. Erase that and try again. As we go up this way, x is getting bigger that way. So that's a direct relationship. And same thing here, as volume goes up, temperature goes up as well. There might be some questions about, I've seen some confusion on this, is which one is more direct. So this one, the most direct, would be right here. Because as one goes up, the other changes more and more. You can kind of see this is an exponential relationship. So as one goes up, the other goes up even more. And then indirect or inverse, as one goes up, the other goes down. So as you can see, as we go across the x-axis is getting bigger, but the y value is going down. And here would be shown as a more inverse or indirect relationship. As one goes up, the other goes down way, way more. So hopefully that helps with relationships. One thing that you'll definitely be doing a lot is working with density. So it's important that you know the formula for density and you know what density is. Kind of some theory stuff. Density is just how much mass in a certain volume. And all matter has a density because all matter has volume and mass. So remember, mass is just the quantity of matter in an object. It never changes, and that's different than weight because weight depends on gravity and will change. And then volume is just how much space is occupied by an object. This is the formula, so density equals mass divided by volume. And then relationally, the higher the mass, the smaller volume will lead to a high density. And if you think about it, looking at an equation like this, if we divide by volume, it's going to make this smaller. So we want this to be small if we want that to be high. And then mass, if I put a bigger number in here, it'll lead to a bigger number there. So we would say that density and mass have a direct relationship, and density and volume has an indirect relationship. And the larger the density, the more likely it is to sink. And density is usually reported in units of grams per milliliter, or grams per centimeter cubed, or kilograms per liter. So when you're getting the units, you're having your mass divided by your volume. So to get your units, you just divide them as well. So if mass was in grams and volume was in milliliters, or volume was milliliters, divide that, you get grams over milliliters or grams per milliliters. Same thing, this could be anything really with the base unit of grams. This could be anything with the base unit of liters or meters cubed. This is where I think that people are struggling the most, is uncertainty in measurement and reading measurement tools, which is something you guys have been doing for a really long time. I think you guys are making this more complicated than it actually is. So whenever a measurement is made with a device such as a graduated cylinder or a ruler, an estimate is required. So if we look where this nail is, we can see that the tip of this is in between 6.3 and 6.4. So there's no graduations on the ruler between that, so we have to figure out, okay, well, what do we do? Do we say 6.3 or do we say 6.4? And really, either of those would be incorrect, because if we just said 6.3, it's more than 6.3, and we can't say 6.4 because it's less than 6.4. So we estimate how far between 6.3 and 6.4 the nail measures. So wherever you can read on your measurement tool, whether it be on a graduated cylinder or a ruler or anything else, you always estimate the last place. So if you break down the distance between 6.3 and 6.4 in equal divisions, we can estimate that the nail, since it's halfway between the 6.3 and 6.4, would be written as 6.35. So whenever you look at a measurement in chemistry, the last unit is always uncertain. The last number of the measurement is based on our visual estimate, and it may be different than when another person makes the same measurement. So therefore, there's some uncertainty in measurements. So the last digit is always going to be kind of our guess, or a guess that someone else made. So if you look at this again, different people could have come up with things like 6.34, 6.35, 6.36. There's really no visual way to say one's more right than the other. Again, the 6.3 is what we're certain about. The red, this last digit is the uncertain one because it's based on us reading it. So let's do some practice. So we're going to use the graduations to fill all the certain digits. And if you're in the chat, if you just want to write what you think, then that's great. So when we read a graduated cylinder, we always want to read the meniscus, which is going to be the bottom of our line, so kind of right here. So what do you guys think? Try to make a guess, and if you want to private message me in the chat, then you can private message me in the chat. Anyone else have a guess? Okay, so let's go through this. So whenever you read graduated cylinders, don't just try to guess from right here. Look at the units that are actually given. So we know this right here is 50. We know this right here is 60. So if we look at the graduations in between, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, which means that each one of these is worth 1. So this is really 51, 52, 53, 54, 55, 56, and so on. So if we look at this meniscus right there, I would say that this is in between 52 and 53. Okay, I know that for a fact. So I know it's 52 point something. Okay. There are 2 unlabeled graduations between the meniscus. Each one represents 1 milliliter, so the certain digits of the reading are 52. We can see that the meniscus is above 52 and lower than 53, so we can say for certain this is at least 52 milliliters. I think I would read this as about 52.8. I think any answer like 52.5 and up to 52.9, I think that would be a valid reading. Because remember, my 0.8 guess is based on what I see visually. It's just an estimate. So if you get 52.7, 52.9, 52.6, that's okay. So when you're working through on your quizzes, just pick the guess that's closest to yours. All right, let's try another one. So this is a 10 milliliter graduated cylinder, and we're going to read this right here. And be sure you're careful with the graduations. Try to look at the 6 and the 8. We got some different answers, so we'll go through. So if we look at this 8 and 6, we can kind of visually see that this one is going to be a 7, because that's halfway in between 6 and 8. So if I look at that, then this is 1, 2, 3, 4, 5 digits to get there, which means each one is going to be worth 0.2. So this is 6.2, 6.4, 6.6, 6.8. So if my meniscus is right there, I would say that I am for certain that it's at least 6.6. And then I would guess the last digit, I said 6.62. 6.61, 6.63, 6.64, those all make sense to me. Even 6.69, I just wouldn't say it's halfway in between 6.6 and 6.8, so I wouldn't go above 6.7. Again, read your graduation. So what do you think the volume is of the meniscus, which remember is the very bottom? Alright, so again, if you look at these graduations, we have 50 to 60, so that'd be 51, 52, 53, 54, 55, 51, 52, 53, 54. I'm going to stop there because it's obviously not above this. So if I was going to say this one, I would say it's at least 52, less than 53, so those are my certain digits, 52. And then I guess my next one, I would say 0.7, 8, 0.9-ish. It looks like it's farther up there. Does that help with reading your measurement tools a little bit? Awesome. Again, just test yourself. This is, meniscus is right here. Right, so if we look at between 70 and 80, they're 1 milliliter graduations each. So starting from 70 to 71, 72, 73, 74, 75, 76. That's where it looks like the meniscus is exactly. I would say 76.0, maybe 76.1. And then 77 would be right there. So we're looking at the bottom of the meniscus. I know this is kind of hard to see on here. But I would go with 76.0.1. All right, so now let's move on to scientific notation. Scientific notation is just how we represent really large numbers or small numbers. M has to be a number between 1 and 10, which just means this part can't start with 0 point something. It also can't be anything above 11. Or 10 for that matter. So this can only be one digit, and it has to be between 1 and 10. So the N part is only counted for significant figures. We'll talk about that a little bit later, but this is the only part you count to determine the number of significant figures. So be sure to have the right number of significant figures, or sig figs, when you report your answer in scientific notation. And then this N right here is an integer. If you started with a number less than 1, then it's going to be negative. If you started with a number that's more than 1, then it'll be positive. So most of you all have seen scientific notation before. We're just going to do a quick little review because the right zeros aren't significant. So whenever you report scientific notation, you only use the numbers that are significant. And the 9. And again, the 9 is how many places we moved the decimal. Since the number we started with was bigger than 1, then it's a positive 9. Was less than 1. We included only 5.79 because those were the only numbers. Alright, so if you have your calculator, I want you to look at it and make sure it's on. I don't want you to type anything in. I'm going to try to show you a trick. So in your calculator, a lot of people make careless mistakes with this times 10 because you have like negatives and then you're supposed to do parentheses and people just get mixed up. So a really easy way to not make mistakes is to use this button called the exponent button. So it might say EXP or EE on your calculator. So try to find that button. I know on mine, I actually, it's not its own button. It's like in the words on top of the buttons on my calculator, and it says EE. And then just let me know if you guys see that. An EE button or an EXP button. And if you don't have a calculator, just tell me I don't have a calculator so I don't wait. All right, good, Hannah. Thank you, Madison. It's usually, if you're looking for it, it's on the left-hand side. Mine's the button above the number 7. There's like an X to the -1, and then EE is right above it. Other people, can you just chime in if you're still looking or if you don't have a calculator? Okay, so Nathan, yours is going to be a little weird because the calculator on your laptop does a really bad job of this. but still try my steps and see if it works. If you don't have a scientific calculator other than the computer, I highly advise that you get one, because it'll just make life a lot easier. They're like less than $10 at the store. Alright, so there are some people that haven't said anything. Can you please just let me know that you're there? So number one, I know that you're here, so that when you tell me you need conversation assessment, we can at least prove that you didn't just turn on the computer and walk away. I'll give you guys about 10 seconds to respond that you're at least here in the class. Just let me know you're here. Okay, so I'm going to go through what you're going to punch in on your calculator. So typically, if you were doing this, you might try to just do 5.44 times 10 and a little caret, and then the 7, then divided by 8.1 times 10 caret 4. But depending on if you use negative numbers, this can get really kind of icky. So instead of hitting this times 10, you're not going to hit times, you're not going to hit 10, you're just going to hit the exponent button. Now, I know on mine, since it's not an actual button on its own, I have to hit the second button to make the little E pop up on my computer. So if I type this in, it should say 5.44 E. So that's what I will type, 7. On your calculator, 5.44, so do it with me. And then hit your exponent button. So again, you might have to hit the second key if it's not the primary function of the button. So your calculator right now should say 5.44 E. And then you're going to just type in number 7. Don't do anything else yet. Don't hit equals. You don't have to type equals on this. You're just typing in a number like you would anything else. You can just hit now divided by 8.1. Again, it's times 10, so you're going to do the EXP button. So my calculator right now says, and then I'm going to type in a and then once you do that, you should get the real answer. Talk about significant figures. I am not a fan of how your lesson presents this. I think they try to make it way too confusing. And just the format of it makes it seem like it's way more difficult. So I'm going to give you rules for sig figs or significant figures that should help clear anything. And then when we talk about significant figures here in just a second, we would only be able to have 2 significant figures. 456 has 4 significant figures. I'll give you just a couple of seconds to play around. So when I say type zeros in your calculator, I just mean the zeros occur to the left box on your of some number that actually is should say 5.4. So anything other than 0. E. So on this first one, left zeros 7 never ever count. So if zeros are to the left of other numbers that aren't 0, they never count. So 0.00486 only has 3 significant figures. Right zeros are a little bit more confusing, but not really. So right zeros count if there is this will save you a lot of careless mistakes. Somewhere in the problem. This isn't anywhere in your lesson. This is just how to use a calculator. This has no decimals, so the right zeros don't count. So this has 3 significant figures. If we look at this one down here, I'm going to go ahead and go on. But there's a decimal there. Extra help with this, or you get confused, my office hours are right after this, and I'll give you guys the link. You just come in and I'll work not a zero find the buttons on your calculator. Left 0 never, right 0. If there's a decimal somewhere in the problem, I think. get frivolous because 670 isn't a big number, and actually write more things by putting it in scientific notation, but these are all zeros on the right. There's my decimal, so that counts, that counts, that counts, and that counts. So that leaves us with 1, 2, 3, 4, 5, 6, 7 significant figures. And then this bottom one is kind of everything together. So these count because they're not zeros. Left zeros never. And then right zeros if there's a decimal somewhere. So there's a decimal somewhere. So yes and yes. So 1, 2, 3, 4, 5. The only other time you have to worry about zeros are zero sandwiches. And calls these different things. But this right here would have 3 significant figures. If you had 5, 0, 5, 0, 5, that's sandwiched in between 2 things that aren't 0. That's sandwiched in between 2 things that aren't 0. So this one would have 1, 2, 3, 4, 5 significant figures. And that's it. Like, that's significant figures. So left zeros never. Right zeros if there's a decimal somewhere in the problem. And 0 sandwiches. I'm going to just ask, we'll go through these one by one. If you want to put in your answers in the chat box, feel free. So that one, how many significant figures? Yeah. This one would be again. The zeros, usually zeros are the only thing that trip people up. So these zeros are sandwiched, so those count. This 0 is on the right, and there's a decimal somewhere, so it counts. So that would be 1, 2, 3, 4, 5. Next one. Yeah, perfect. 4. There's a right 0, there's a decimal somewhere, so it counts. Next one. Okay, so this one's tripping people up a little bit. So think about the zeros as they occur. So these zeros right here are sandwiched in between 2 real numbers, so they count. Obviously the 1 and the 8 and the 9 count because they're not 0. And then this last 0 right there, it's on the right, but there isn't a decimal in the problem. So 1, 2, 3, 4 significant figures. The next one. Yeah, perfect. So this one only has 3. Whenever you look at scientific notation, you only count before the time is 10. What about that one? 0.0054. Good job. Remember, left zeros never count. So 54 is the only thing that's significant. What about that one? Alright, so this one has 2 as well. The zeros are on the right, there's no decimal, so it's not significant. When you guys are doing this, and using significant figures actually in chemistry, you're mostly going to be using this rule right here. The rules for significant figures when you multiply and divide. When you multiply and divide numbers in chemistry, you have to report your answer with the fewest number that exists. It sounds really complicated, but if you look at 6.38, how many significant figures are in that? Yeah, perfect. 3. There's 3 significant figures in 2.0. How many significant figures? 2. Our answer can only have 2 significant figures because 2.0 only has 2, so we can only report 2. So if you plug this in your calculator, you get 12.76. but we have to round this to two significant figures, so we round to 13. I'm going to plug all these in because it would take way too long. I just want to look at them. So in 3.24 times 7.0, how many significant figures should your answer have? 2 is correct. So if you plug this in your calculator, you would get 22.68. If we wanted to round this to only two places or only two significant figures total, we'd have to round up to 23. And the meter squared is just the unit. It's irrelevant to what we're looking at. With the next one, 100.0 divided by 23.7, how many significant figures should our answer have? Perfect, 3. That's what you would get in your calculator. So we go to 3 decimal places, or to 3 places total. We would round to 4.22. The next one, how many significant figures should we report our answer as? Okay, so if we look at 0.02, how many significant figures is there? Yeah, 1 is correct. So that means my answer can only have 1. So don't get freaked out if you can only report in 1. Do what the problem wants you to do. So this has your answer as 0.04742 in your calculator. So to round to only one significant figure, we would just say 0.05. You know how many significant figures you should have because your answer has to be reported the same number as your lowest number of sig figs that you started with. So this had 3 and 2. The first one, 3.24 times 7.0. This one had 2, so our answer can only have 2. This one has 4. This one has 3, so this one has to have 3. This one has 1. This one has 4, so this one can only have 1. So you just go with your smallest number. 710 divided by 3.0, how many significant figures should I have in my answer? Perfect, Cam. Yeah. So when you put this in your calculator, now this one's kind of tricky. You get 236.66666666 till the end of time. Okay. If we rounded to two decimal places, if we just rounded this number, probably like you would probably go like 237. But how many significant figures does 237 have? Yeah, so we got to keep rounding until we get to 2 only. So if we round this up one more place, you end up getting 240. Rounding and stuff, it'll come as you guys work through some problems. I think you guys got this. I'm going to skip ahead. I don't think this is given to you in your problem. No, addition and subtraction has slightly different rules. Instead of counting the total number of significant figures, we would go with decimal places. So this has 1 decimal place. This has 3 decimal places. You can only report with 1 decimal place. I don't want you guys to worry about this one too much. We would just look and say, okay, 2 decimal places, 1 decimal place. We only have 1 place after the decimal. You guys won't have to worry about this. I'm just putting this in here that there is something different. Okay, the next bit of class, like we're going to stay in here for maybe another 5-10 minutes. It's just going to be a quick review on metric prefixes. This right here is really, really, really important for you to know and memorize. So 1,000 grams equals 1 kilograms, a meter is 100 centimeters, a liter is 1,000 milliliters, and 1 milliliter is 1 centimeter cubed. Those are things that you should definitely know off the top of your head. So you're given all these prefixes. You should know what they stand for and their exponent. So if you need more help with this, again, you can come to my office hours. This is just supposed to be a review and me touching on the place where people are having the most. Into my unit before, or to my class before, we did King Hector died by drinking chocolate milk, and that just gave us our order of prefixes: kilo, hecta, deca, and then our base unit, deci, centi, and milli. So remember, it's easier to remember dumb things than smart things. So King Hector died by drinking chocolate milk. That should help you write your K, H, D, B, D, C, M to do your metric conversions. We also added in the U and the N. Remember, this is 10 to the negative third, and this is 10 to the negative 6, so you have to leave 2 open spaces for where there'd be 10 to the negative 4, 10 to the negative 5, 10 to the negative 7, 10 to the negative 8, because nano is to the negative 9. Same thing, kilo is 10 to the third, mega is 10 to the 6. So you have to leave spaces. So remember, as you write out your little tool with King Hector died by drinking chocolate milk, you look at the unit you're starting with, where you're going, whichever way you have to move, then move your decimal that way, and however many places, move that many times. Okay, so I'll just do a couple real quick. So King Hector died by drinking chocolate milk. Really, you won't be using a lot of these. I don't know when you would ever really use mega in chemistry, because chemistry we're concerned with things that are so small like the atom, but there it is. So 6.33 milligrams to hectograms, so we're starting in milli, going to hectus, so we're moving to the left, and we would go 1, 2, 3, 4, 5 times. So 1, 2, 3, 4, 5 times. So we get 0.0000633. If we look at the, I'm actually going to go down to the third example. Make sure whenever you see this, you know what this means. So this M means milli. If we were to actually read this, we're trying to do 125.8 centimeters equals blank meters. That's not milli. So on this one, we're going from centimeters to meters, which is a base unit. Remember, your base unit will always be one letter. So like grams, meters, liters. So this would be 1, 2 places to the left. So 1, 2 places to the left, 1.258. Make sure you know the difference between this and this. So this is deci, this is deca. And again, I've already done a class over this. If you don't feel good with metric conversions and you want more refreshers or just more help, then come and get it in my office hours after this. Go through dimensional analysis again real quick. Again, this just allows us to cross out units. Steps here. We're more complicated than it actually is. Basically, we determine what number we're starting with. We write it in our first little train track. We copy our unit onto the next bottom, and then we just start our conversions until we get to the unit that we need to be in, multiply and divide, and then report our number with significant figures. So the reason I'm going back over this is to talk about significant figures again. This is way more complicated looking than it actually is, but I like giving as detailed of steps as humanly possible. Another tip, if you like being super cautious, is just whenever you set up your conversion factors, determine which one is the bigger unit. So for example, a meter is bigger than a centimeter, and then automatically put a 1 next to the larger unit. It'll make things easier. And remember, conversion factors should always be equal to each other. So in this one, convert 10 meters to millimeters. So I'm just going to show you what to do. So first thing we do is set up our little train track. out what numbers they give us to start with. So they want us to start with 10 meters in our first rung. Meters needs to cancel out. So if I wanted to cancel out meters on top, I need to have meters on the bottom. Then the next bottom. Ask myself, okay, do I know how to get from meters to millimeters? The answer is yes. We should know metric prefixes, and then we say how they're related. So 1 meter equals 1,000 milliliters. If we look, our meters would cross out because one's on top and one's on bottom. To solve this, you're going to multiply everything on top. So it'd be 10 times 1,000. Multiply everything on bottom, but there's just a 1. So if you plug this in your calculator, make sure you do parentheses 10 times 1,000 parentheses divided by 1. When you hit equals, you get 10,000 millimeters, or if you want to write it in scientific notation, you can do 1 times 10 to the 4th. Our answer has to have one significant figure because 10 only has one significant figure. So 10,000 still only has 1 because those zeros are on the right and there's no decimal, so they don't count. Let's look at the next one, meters to kilometers. So how many significant figures should my answer have? Yeah, perfect. Should have 1. So make sure whenever you're done with your problems in chemistry, you go back and you double check, does my answer have the right number of significant figures? And you're always going to come back to the actual question, the number that you start with here on your wrong. You're going to use. Don't worry about these middle parts. They don't count. They're conversion factors. We never use them in figuring out number of significant figures. Okay. So we put meters on the bottom. You can directly go to kilometers, then we fill out the relation. 1,000 meters equals 1 kilometer. Now if we multiply it all across, we'd have 20 times 1, and on the bottom we'd have 1,000. So if you type this in your calculator, you can get 0.02. That should take kilometers. Would it be okay for me to put 0.020 kilometers? No, because this now has 2 significant figures, but my answer can only have 1. This one says convert 5.2 kilograms to milligrams. I'm showing you this one because you're going from one prefix to another. And whenever you're trying to do that, always go through your base unit first. So I'll show you what I mean. So how many answers should how many sig figs should my answer have? Okay, perfect. We're going to start 5.2 kilograms. You want to cancel out kilograms, so then you need to go to the next bottom. Now, technically, I can get from kilograms to milligrams, but I know that I would have to, and I could use my little, just moving a decimal, but in chemistry, you're hardly ever just going to move the decimal. Your conversions between metric units are usually going to be in the midst of another type of problem, so you're going to want to set it up in your factor label. So I know personally off the top of my head, I don't know how many milligrams are in a kilogram, but I know how many kilograms or grams are in a kilogram. 1 kilogram to 1,000 grams, and I know grams to milligrams. Whenever you're going from one prefix of kilo to another prefix milli, and they have the same base unit as grams, then go to the base unit first. So I went from kilograms to grams, then I'm going to go grams to milligrams. And again, we would fill out 1 gram is 1,000 milligrams. We multiply all the top. So we'd have 5.2 times 1,000 times 1,000 over 1 times 1. You hit equals, and you would get 5,200,000. You could leave it like that, and you could write it in scientific notation. It doesn't really matter as long as your answer has 2 sig figs. This one says convert 1.4 days into minutes. And I'm just showing you how to set these up, hopefully give you some more confidence in review. We start with 1.4 days. And since 1.4 has 2 significant figures, our answer can only have 2 significant figures. If in days. I don't particularly know how many minutes are in a day off the top of my head without doing a calculation. Go to what I know. Days into hours. So 1 day equals 24 hours. Still not done because days canceled out, but hours is still there. I gotta keep going. My hours goes on bottom. Hour equals 60 minutes. Cancels out. I'm in minutes. It wants minutes, so I can solve. So if I type this in my calculator, I would do parentheses 1.4 times 24 times 60 over 1 times 1. I get equals 2015. How many significant figures does 2016 have? 4. Perfect. How many can I report my answer in? Yeah, I can only have 2. So this is probably one of the the place people mess up the most. So if I rounded the 6 up, I would have 2020. But how many significant figures does that have? Yeah, that's 3 significant figures, so I can't use this. If I try to go to the next place, if I just tried around the hundreds place, the 2 would keep it the same, and then I'd have that. But how many significant figures is there? Yeah, 1 significant figure. So I can't use that either. So if you get to a problem and you don't know how to fix the sign or the significant figures to be correct, put in scientific notation. So now I changed this to just say 2.0. So I'm kind of going off of this one and this one. But I'm making scientific notation so people can just put that decimal in there and have you write significant figures. So that's why I showed you this one. So if you get in doubt and you're like, I don't know how to report this in the right number of significant figures, use scientific notation to help you out. This says convert 389.5 centimeters into feet. Again, we start with 389.5 centimeters. Centimeters will go on bottom, inches on top. I'm doing that because of this right here. Again, I'm only going to count that towards my answer in SigFig. So how many significant figures should my next answer have when I'm done with this problem? Yeah, 4, perfect. Use my conversion factor, 2.54 centimeters equals 1 inch. I'm done because I want feet, so I go inches to feet. Next to 12 inches equals 1 foot. When I go to solve this, because now I can solve, because my centimeters and inches are canceled out, I'll do 389.5 times 1 times 1 divided by parentheses 2.54 times 12 parentheses equals. You put that in your calculator, you get 12.77887. I have to have 4 significant figures. So I look at this one to tell me if I need to round up or not, and I do. So I say 12.78 feet. Have any questions? That's much one in about 45 minutes or so. 45, 50-ish minutes. Is there anything that I can help you with at all? So hopefully that helps.